back. We just took a look at the sine function. Let's look at the cosine function. So now if we let y equal the cosine function, let's plot some points here, like 0. You know, what is the cosine of 0? Well, we know it's 1, all right? So 0, comma 1, let's put it on there. Now let's go pi halves. Cosine of pi halves is 0. So pi halves, comma 0. Let's go pi. Cosine of pi, negative 1. Pi, comma, negative 1. 3 pi halves. Okay. 3 pi halves, we got 0. Right? Cosine 3 pi halves, 0. Cosine at 2 pi, 1. Cosine of 5 pi halves, 0. So that'd be around 1s plus pi halves more, right? The cosine there is 0, the x value there. 3 pi, negative 1. 7 pi halves, 0. 4 pi, 1. And so on, okay? Yeah, if you're not sure on seeing if you know on the curvature here, you can always pick, you know, you say cosine of pi fourths. You know, pi fourths is about 0.785. So if you're plugging in, if you wanted some additional points, you know, this is about 0.785. Pi fourths is, and then the y value there is 0.707. 0.707. Okay, so pi fourths, you know, that's about. Actually, I'm just right in between 0 and pi halves, right? That pi fourths, and I'm at 0.787. Okay. You know, maybe I want even less than pi fourths, like pi sixths. You know, what would pi sixths give me? Well, we know that the cosine of pi 6 is root 3 over 2, right? Root 3 over 2, which is about 0.866. 0.866. So again, or root 3 over 2. Okay. So pi 6, you know, is a little higher right here. So it's kind of coming down. It's giving you some curvature here. And then we follow this cosine curve. Okay, and that thing keeps going. Let me erase some of this extras here. Can't get that. And of course, you can plug in cosine negative pi halves. Well, that's 0. Cosine negative pi, negative 1. Anyways, and so on. So that keeps going. Well, let's name our domain. Domain again, all real numbers. All reals. Okay. And your range, you notice that your range goes between a low value, y value of negative 1, and a high value of 1. Okay, domain range. You notice your x-intercepts this time. You see them, put them in black here. So negative pi halves, 0, pi halves, 0, 3 pi halves, 0. See all these x-intercepts here? Okay, so we have a bunch of x-intercepts. Let me start with that pi halves, 0. Then you got the 3 pi halves, 0. You got your 5 pi halves, 0, and so on, right? Of course, you got that negative pi halves too, but they differ by, you know, pi amount there. Okay, your y-intercept now is 0, comma 1. Y-intercept 0, comma 1 here for the cosine function. Okay, now let's look at the period on this thing. Okay, I like to start again at one of these x-intercepts. So let me take a look here from here. Now let's follow this. Let's go to there, and I'm like, oh, I repeat that pattern again, right? Let me repeat the pattern in red. Oh yeah, how far is that? So that's one period from here to there. What's the difference between 5 pi halves and pi halves? 5 pi halves minus pi halves, 4 pi halves. Or in other words, this has a period that's also 2 pi, just like that sine function, right? So There's your period. What's your amplitude? Your amplitude, half the distance between your low and your high, right? What's that distance? Well, the distance is 2, but the amplitude is half that. So the amplitude is half that distance, which is 1. Okay. Now, some similarities you probably have noticed between the cosine and the sine function. Okay. It's the exact same thing, except it's, the sine function is pushed over. It's pushed over a little bit. So if you look like, how much, right? Well, what's the difference there? Do you see how if you took this sine function and you moved it back pi halves, you would have the cosine function. Okay. Might even want to put those into your calculators. You might see that. Okay. So, because we're now going to look at, so the cosine and the sine, same thing, except there's a difference of pi halves right there. Okay. Or same behaviors, I guess you will, in a lot of ways. Okay. So let's take a look at the graphic effects of constants A, B, C, and D. So if we were to kind of generalize these, if you have A sine times the sine, let's go bx minus c plus d, and a cosine bx minus c plus d. All right, the d on the end there. What do the constants A, B, C, and D do? Okay, that's the question. Well, as you probably will have guessed, C moves this thing right or left. Okay, so that's a horizontal shift right or left. Okay, similar to when we did um, shifts with our, rigid transformations with like our quadratics and our cubics, all those things, right? That D right there is going to be a vertical shift, up or down, right? Up or down. So if that D value is positive, it's going to go up. D value is negative, it's going to go down, right? Okay, same thing to C and D for that cosine function. Now the A and the B there, okay? The B is going to give us the period, okay? Because that's how much that you're horizontally stretching this thing or shrinking that thing, okay? So we want to just remember here, let me point to this B, and the equation is given by the period is 2 pi over B, whatever B is, okay? And then that A is for our amplitude, okay? The amplitude here. And to get that amplitude, it's simply the absolute value of A, okay? Amplitude is the absolute value of that number. Now, if you have the absolute value of A is greater than 1, you're going to notice a vertical stretch. I could have guessed that based on past functions. And if that absolute value is less than 1, of course, you're going to have a vertical shrink. Okay, vertical shrink there. So let's go ahead and let's sketch a few here. Let's look at some, like 2 sine of x, for example. Okay, extend this a little bit. 2 sine of x, okay? So you're thinking about a sine bx minus c plus d, right? You're like, okay, the only difference between this and the regular sine function is you see how your a value there is 2? So your amplitude has changed, okay? Your amplitude has changed, so your a is 2, and you want to note that. You want to say, well, I'm going to note my amplitude is the absolute value of 2, which is 2, okay? So this is going to end up vertically stretching your sine function. Okay, so you got a vertical stretch here. There's no movement right or left. C is 0. The period, period Period OD period is 2 pi over B. Now you notice your B is 1, right? You see that 1 right there? Well, I just wrote it in. So it's 2 pi over 1. So I still have a period that's 2 pi, right? And then C is 0, D is 0. So there's no movement right or left, and there's no movement D up or down, okay, on this one. So it's just 2 sine of X. And then we graph this thing. So we say, well, let's start out again. Let's start out, 0. Let's plug some points in. 2 sine of 0. Well, what's the sine of 0? I say, well, the sine of 0 is 0, right? 2 times 0 is 0. So 0 is 0. Okay, if I'm getting a bunch of x, y values, 0, 0. I just plugged in x to be 0. Now we punch in pi halves, right? So 2 sine pi halves. I say, well, the sine of pi halves is 1. So now at pi halves, all of a sudden I'm up at 2. Right? Remember we said this would vertically stretch. Our amplitude ends up being 2 in this case, right? So pi. Well, what's the sine? Sine of pi. And we say 0. So 2 times 0, 0. 3 pi halves. What's the sine of 3 pi halves? I say that's negative 1. So I got negative 2. So 3 pi halves, I'm at negative 2. Right? That's 3 pi halves. Now at 2 pi. Now, so what's the sine of 2 pi? 0. 0 times the 2 in front. 0, right? So this thing ends up, and I'm pretty confident in this already. So I'm going to stop there. So I'm assuming you can keep going on that. At 2. Okay, and so on, Sine negative pi has be negative 1, negative 1 times the 2, negative 2, and so on. Anyways, okay, you kind of get the idea, okay? It's just like that sine function again, but it's vertically stretched by a factor of 2 there. Our amplitude is 2. You notice the distance between the high and low. That distance is 4. Amplitude, half of that. Amplitude is amplitude, if you want to say that's amplitude 2, right? Half the distance between high and low points. Okay, but there's our graph, 2 sine of x. So the 2, vertically stretches that. About this one, 1/3 sine of x. What's that going to do? Well, my amplitude is absolute value 1/3. Oops, absolute value 1/3. Nuts, change that. A third. Okay, so our amplitude is a third. Our period, 2 pi over b. Our b right here is 1, so 2 pi over 1. So period's 2 pi again, right? So this thing is going to end up being a vertical shrink because our amplitude's 1/3. So. And then there's no shift right or left. Neither is there a shift up or down on this thing. So let's graph a few points here. Again, I'm going to go by half. And so on. Alright, here we go. 1/3 sine of x. I say, well, what's the sine of 0? Sine of 0 is 0. 1/3 times 0, 0. Alright, let's plug in pi halves. Sine pi halves. 1. 1/3 times 1. Oops, sorry, I plugged in pi halves. I got 1/3. So pi halves, and I'm only a third of the way up, right? Sine of pi. Sine of pi is 0. 0 times the third in front, 0. Sine of 3 pi halves, right? I'll write this one down for you. So we're down to negative a third, right? About right there. 2 pi, sine 2 pi is 0. 0 times the third in front. Anyways, I can get a few more if I needed them, but I'm, confident. I'm like, oh yeah, I know what this thing looks like. Sine of negative pi halves negative 1. Negative 1 times the 1/3 times the 1/3 in front, -1/3, right? So on, so. And you can again see that, hey, my period is 2 pi, right? My amplitude is 1/3. You see how it only goes up, 1/3 there of the way from that x-axis. The distance between them is 2/3. Okay, so half that distance. Anyways, 1/3. Okay, so that's what that 1/3 in front does. That is a vertical. That is a vertical shrink. Okay. And of course, we could move this up or down. Like if we said, what is 1/3 sine x? Let me move it right. Let's move it right. Pi halves, and then let me move it up 1. Let's do that. Okay. Let me take this origin point. So if we go right pi halves, we're to right here, right? It's actually right. We're right pi halves. Here's my origin point, and then I'm up 1. Boom, there it is. Okay. Let me take the next point. Let's take this one in green. Okay. That local max right there. I'm right pi halves amount, and then I'm up 1, so it's about right there. Okay. Let me take that 3 pi halves, -1/3 point. So I'm right here. Okay. Oh, I'm sorry. I need to be taking my pi. Jeez. Take my pi. So I go right pi halves and up 1. Okay. See it right there. Do the next one in blue. My 3 pi halves -1. Now I'm at this point here in blue. Okay. I go right pi halves amount, and then I go up 1. Okay. Anyway, so you got this thing, and you're looking exactly the same and so on, right? If you want to think about that x-axis as like kind of been bumped up one, right? So it should be going along that thing. Anyways, and so on. Okay, so that's what would happen if you moved it right pi halves amount, you moved it up 1. Okay, and that's one good way to think about moving those points. But you can also plug in points. If you plug in pi halves now, you're going to get 0, right? So, anyways, or I'm sorry, if you plug in pi halves, you would get sine of pi halves minus pi halves, which is the sine of 0, which is 0. 0 times the third in front is 0, and 0 plus 1 is 1. Okay, so that's why we had that point pi halves comma 1 right there. You plug in pi, and you should get 1 1/3, and so on. Okay. So point plotting will always give it to you as well, the behavior there. All right, let's take a look at some more translations, vertical, horizontal translations. How about what would 2 cosine of x minus pi halves look like? Get a good one here. Or you know what? Let me move it. How about this? X minus pi. Okay. So that right there is going to move your cosine function to the right, pi, and then your amplitude is now 2, right? So your amplitude, it is 2. Okay, absolute value 2, which is 2. Okay, so if you're thinking about, maybe you even want to draw the old cosine function initially, right? The cosine is 0 is 1. Cosine of pi halves, 0. Cosine of pi, -1. 3 pi halves. Okay, so here's just your old cosine, right? So what this thing's going to do is we're going to move it to the right pi. So let's take this point, and we're like, hey, I got to move that to the right pi, right? There it is. Let's take that pi halves point and move it to the right pi. There it is. right? Let me take this, how about this negative pi halves point? Negative pi halves, I move it to the right pi, right? Right there. Let me take this pi point, pi -1, I'm going to move it to the right pi, and so on. So anyways, we got this, like, oh yeah, okay, and so keep going, right? Okay. Now I did one thing wrong here. I moved everything to the right pi, but I have to consider also my amplitude is 2, right? So this is going to stretch it out as well. So instead of having the point pi comma 1, I got to make sure that I stretch this thing out. And this is doing it without points, right? I'm like, hey, these all have got to be stretched. You'll clear up to here, clear down to here. Okay. So, so on. Okay, so let me draw this a little better. Anyways, and so on there. Okay. You know, and again, checkpoints, right? So let's plug in 0. Let's plug in 0. What does 0 give you? And you're like, well, cosine at negative pi, if you rotate negative pi, right? You rotate negative pi, again, where are you at? You're at -1, 0. Cosine there is -1. So 2 times -1, -2, right? So we plugged in 0 for x, and it spit out -2. 0, comma, -2. You see it here in black? Boom, right there. Okay? You plug in pi halves. And you're like, okay, do that too. Cosine, plugging in pi halves. 2 cosine, now that's a negative pi halves. You rotate negative pi halves, -90 degrees, your cosine there is 0. So you got 2 times 0, which is 0. Oh, you see the point right there? Plug in pi. You know, pi minus pi is 0. Cosine of 0 is 1. 2 times the 1 in front, 2. Okay? Anyways, you can keep going on this. You get all these points, right, by point plotting as well. So, you draw it, connect those. We already drew it, didn't we, considering our amplitude. Okay? So that's what 2 cosine of x minus pi is going to look like there. All right, so sorry. Let me find my next exercise here. All right, what if we were to use a calculator to graph some problems here? Let's use the, you know what, let me stop. I got to use a different window when I do this.